Hi. So today's topic for discussion is superconductivity. So in recent times, this term of superconductivity, it has gained a lot of prominence. The thing is, superconductivity is not a new thing. It has not been discovered recently. It is something of the past, but it has much potential. And why recently it came in news, or why recently it created and furore in the scientific community, is that a couple of scientists from Korea, they have claimed that they have achieved superconductivity at room temperatures. Superconductivity is something that can only be achieved, that can be achieved near absolute zero. At very low temperatures, superconductivity can be achieved. That is when particles will allow superconductivity. But these Korean scientists, they have claimed that they have achieved superconductivity at room temperature. So this is what the issue, this is what the context of this particular scientific terminology being in use. So what is superconductivity? But before getting into superconductivity, we'll see what is conductivity. What is conductors? We all know what conductor is, right? Something that can, something through which current can pass through, electric current can pass through, is known as conductors, and we separate or we classify conductors as good conductors and bad conductors. So this good conductors and bad conductors or insulators is based on their resistance level. What is resistance? Is that electrical resistance. A particle will not allow all the current to pass through itself. For example, we'll take a wire and give 50 units of current through that wire. We'll take a copper wire or silver wire, any metal wire for that matter. We'll supply 50 units of current through that wire, and the output at the other end will only be 40 units. For example, I'm talking about the example, not the exact value here. I'm talking about an example. So this balance 10 units is resisted. It is the behavioral element, it is the characteristic of that particular metal or particular conductor to resist electric charge. So this is what resistance is. So resistance per se, it is not a bad thing, but a lot of issues can happen when it comes to resistance. And one particular statistics tells us that around 5% of electricity transmitted in the United States of America is being wasted through resistance. 5%. USA is a very big country, and 5%, it is a very large amount to be wasted by resistance. This 5%, it can be used to power the entire Central American countries. Central American countries, there are Jamaica and all these countries, Caribbean countries, right? These Central American countries, 4 times this 5% can be used to power these Central American countries 4 times over. So for 4 years, this 5% can be used. So resistance is that thing that has, if it is reduced, it is very good. So resistance has other uses also. For example, in our toaster ovens, right? Toaster ovens, bread toasters, we use heat to toast the breads. So where does this heat come from? Is through resistance. When resistance is higher, heat generation will be more, and through this resistance only, our breads come out as toasted, well toasted pieces of breads. So yes. So this is, so resistance is not per se bad, it is also not per se good. So yes, now what is superconductivity? Superconductivity is that some metals or some elements, they have the superconducting properties at very low temperatures, not in general temperatures, but at very low temperatures. They have this property of superconductivity, that is, they will not have any kind of resistance when a current is passing through them. So this is what superconductivity is, and if it is achieved at room temperature, it will be groundbreaking in physics. Actually, it can also lead to Nobel Prizes and all these things if it is achieved in room temperature, but generally it is achieved only at very low temperatures. So the history of superconductivity is that very first time a Dutch scientist named Heike Onnes, a Dutch scientist named Heike Onnes, he used mercury to prove superconductivity at very low temperature, close to zero, close to absolute zero. He froze mercury, and through that he proved us that superconductivity is present, and all these things were shown. So this is what in general superconductivity is, and we will see what are the applications of superconductivity. So the applications of superconductivity. So yes, the first thing is MRI. MRI, we all know MRI scans, right? Magnetic resonance imaging. So this is what MRIs are. So these MRIs, what they use is that they use a magnetic field. They use a magnetic field and radio waves to get a clear-cut picture of the insides of our body. So this is what the MRI does. So this MRI needs radio waves and magnetic field. So this magnetic field can be given by superconducting materials. Yes, traditional magnets will also give magnetic fields, and superconductors will also give magnetic fields. But the magnetic field given by superconductors, it will lead to much more accurate and sharp pictures. So when imaging the internal of our body, sharp pictures are needed, like for analysis and all, to diagnose and all, we need clear-cut pictures. So this can happen when it comes to MRIs. Superconducting materials and elements are used for magnetic resonance imaging scans, that is MRI scans. So yes, next thing is power transmission. So yes, we saw this example of how 5% of USA's power transmission, like 5% of energy of USA is lost due to resistance, and how it can power other countries also, like 4 times over it can do, right? So yes, so in power transmission, when superconductivity used, this resistance can be nullified, this resistance can be thrown out of the table, it will not be on the table. And when this resistance is not there, we will be more energy efficient, we'll only need less energy, and it will also be beneficial for the environment also, so that we will not produce much more energy, because some part of the energy is saved from resistance, saved from using superconductivity. So yes, the next thing is quantum computing. So while understanding superconductivity, another thing that has to be it cannot be missed is that of quantum mechanics or quantum physics. So superconductivity and quantum mechanics, they are interlinked intricately. And they both act in their own ways. And when it comes to quantum computing, superconducting materials are used on a large scale. To improve the efficiency of quantum computers. So computing efficiency can be improved by using superconducting materials in quantum computers. So that is another thing. And fusion and sustainable energy. So we all know what fusion is. The nuclear energy, right? Fusion, when 2 atoms are combined, it leads to enormous energy. But this can be achieved only at very higher temperatures. When we talk about nuclear energy, we usually talk about this fission reaction, that is opposite reaction that comes from splitting a particular element. Like mostly uranium is being split into kryptonium and barium to produce energy. But here, when it comes to fusion, 2 elements are being joined together. Deuterium and tritium, they are being joined together to form high amounts of energy. But to achieve this type of fusion, what we need is that enormous heat. So this process is what is replicated in the suns and all these stars also. But yes, sun is something that is very hot, right? So for fusion reaction to take place, we also need very high temperature. So this high temperature, it can be supplied by something called as plasma. In this fusion reactors and all, something called as plasma or hot gas, it gives very high temperature or very high temperature. The thing is, it has to be sustained. It has to be kept within itself. It has to be sustained. That heat must be sustained, right? That is where the superconductors come to play. The superconductors and the magnetic field that they give, the magnetic field that superconductors give out. These magnetic fields, they keep the plasma inside. They keep the heat inside. So this is how fusion reaction is being done in India. In the world today. And India is also part of this thing called as the ITER tokamak. So in fusion reaction and sustainable energy also, superconductivity has various applications. Next is transportation system. So yes, when it comes to transportation system, superconducting materials and superconducting mechanisms have been in large use. The thing is, when it comes to what comes to your mind when we talk about Japan? Japan is highly developed animes and trains, magnetic trains, magnetic levitation trains. So these magnetic levitation, what they do is that they use superconducting magnets or superconducting materials to move. Magnetic levitation means they levitate. If this is the track, these trains, they levitate with the help of superconducting materials and magnets, and through this only they move. There will be no contact with the ground, they will move. So this can also be used, superconducting materials or superconducting elements, they can also be used in transportation systems such as the bullet trains and this magnetic levitation trains. The name of the train itself is that SC maglev. Superconducting magnetic levitation. So that is what its name itself is. So these are the various applications of superconductivity. Now, what are the challenges with respect to superconductivity? The first major challenge is that it is very high cost. High cost in the sense, yes, there are cooling systems like superconductivity cannot be achieved at, it has to be achieved at very low temperatures, right? Yes, so cooling systems are needed. Very low temperature is needed. So all these things, and superconducting materials, they have very high, like they are costly. Some materials are costly. Yes, copper is there when heated and all. Sorry, when reduced in temperature, these all superconduct. Yes, there is elements are there, but some elements are very costly. So high cost of superconductivity is one issue when it comes to using superconductivity in all these applications that we have seen. Another thing is low critical temperature. Low critical temperature is that always it is not sustainable. It cannot be used anywhere. Sorry, it cannot be used everywhere. It cannot be used everywhere. So low critical temperature is very difficult to attain, and also it cannot be used almost everywhere, right? So only in some certain places this superconducting materials and low temperature can be used. So that is another issue. And the third issue is that when handling superconducting materials, these superconducting materials are fragile, so bleak, they are so fragile and they are difficult to handle. They can easily break and all these things can happen. Like yes, when you cool something to that extreme temperature, they become fragile. So they are difficult to handle. They cannot be easily handled. So these are the major issues when it comes to superconductivity, using superconductivity in these applications. But yes, successfully we have been using in all these applications also. Not India, but yes, we are moving towards this magnetic levitation trains and fusion based reactions and all. Not India, not indigenously, but with other support from other countries, we have been using superconductivity. But what India has done when it comes to superconductivity is that National Superconductor Mission has been introduced. 2017, the Department of Science and Technology, the Department of Atomic Energy, and CSIR, Council of Scientific and Industrial Research. So CSIR, all these three together, they are starting to implement this particular mission called as Superconductor Mission, National Superconductor Mission, which was launched in 2017. What is the goal of this mission? Is that to produce or to develop indigenous superconductor technology. Indigenous superconductor technology that can be used for various purposes. It can be used for quantum computing, it can be used for transportation systems, power transmission. We have seen the applications, right? So what this mission tries to do is that it tries to develop indigenous superconductor technology. So yes, this is what the goal of this mission, and yes, it has also attained significant success. Thank you.